Okay, so we're going to talk about the rock cycle. And really, what we're talking about is the three main types: igneous, metamorphic, and sedimentary rocks, and how they can all turn into something else or go back to being exactly what they were, but in another form. So let's start here at magma. All right. By the way, this would be melting, but let's start here at magma. So if we have magma, that is molten rock deep underground, and it starts to cool and crystallize. So at A, we're at crystallization. So we're taking magma and it's starting to cool and grow big crystals. And once it's completely cooled, we go up here to our igneous rock. Okay, let's go around the outside of the circle. So igneous rock, and this is just one way to show the rock cycle. The point is, it's pathways to go any which way. You just have to follow the arrows to figure out what's what. So if A is crystallization, which gets us to our igneous rock, then let's say I go up to B, and that's our weathering and erosion. So we're starting to break down that rock. And then we get to C, where it's transported and then eventually cemented together. Once it's done with the cementing process, you have a sedimentary rock. Now, if a sedimentary rock is heated and put under pressure, but not melted, and that's here at D, and that would be our heating and pressure stage, then we get a metamorphic rock. And if our metamorphic rock now goes a little too far and actually melts, we have melting occurring, it goes back to being magma, and we go back to being an igneous rock. Now, let's say the igneous rock somehow gets recycled back underneath. It gets pushed down far enough where it gets close enough to the mantle where it actually, guess what, melts again. It can go back two ways depending on how far it goes. If it starts the heating and pressure, and gets to this melting point, so this F is heating and pressure, not quite melting, but it can get to melting and become another igneous rock. Or it can go through F with heating and pressure and it can become a metamorphic rock. So at this point right here, an igneous rock can go back to being metamorphic, or it can go back and become another igneous rock, or it can get weathered, go this way and become a sedimentary rock. Now, if a sedimentary rock or a metamorphic rock actually starts getting broken down with weathering and erosion, now that's the same process we did here. That's weathering erosion. It gets transported and cemented. It goes back to being a sedimentary rock. So sedimentary rock can travel back upon itself and become another sedimentary rock. A metamorphic rock can become an igneous rock, or it can become a sedimentary rock. So any rock can become any other rock if it goes through the right stages. So we have A, that's our crystallization. We start with magma, it gets crystallized, it becomes an igneous rock, it gets weathered, it gets transported and cemented to become a sedimentary rock, which can go under heat and pressure to become a metamorphic rock, which can melt to become magma and go back through it. Igneous rocks can go under heat and pressure and either go to the magma stage, the melting stage, and become another igneous rock, or if it doesn't quite melt, it becomes a metamorphic rock. And we can take sedimentary rocks, or metamorphic rocks, or igneous rocks, all go through the weathering, just through a slightly different path, and we can go back to being sedimentary. So any rock can become any other rock, hence the term, the rock cycle. So if you didn't get that, you should probably pause and go back and answer those questions that I just gave to you. Number 2 says, all of the rocks follow the same path of the rock cycle. No, they can follow any path. It just happens to be, do they get weathered? Do they get melted? Do they just get heat and pressure? What do they get? So no, not all rocks follow the same path. If we watch this video, maybe, the rock cycle explains how rocks are transformed from one rock family to another. So what you're going to do now is watch that video, which is just going to reiterate what I just did, and answer that. The rock cycle explains how the rocks are transformed from one rock family to another. Here's a hint, it's true. But that's a really good thing to go back and watch if you don't want to watch this whole video again. Match the following with the formation of rocks. All right, so first of all, let's look at question number 1. How does granite change into sandstone? So we've got a choice of crystallization, weathering, and erosion are required to produce sediments. Shell organisms are ground up by waves and form a rock. Heat and pressure from buried changes the rock, or melting. So, which of those makes the most sense? How does granite change into sandstone? Well, that seems to me that it would be weathering and erosion are required. So for me, this would be B. Now, in your column, it's probably different, so be careful. Don't just put down my letters, but put down what it actually is. The next question, too. How does sandstone change into quartzite? Quartzite is a metamorphic rock, so there can't be any weathering and there can't be any melting. So now we're looking at D for me. Heat and pressure from burial changes the rock. That's the process. Intrusive igneous rocks form large crystals through what process? So an intrusive igneous rock. Okay, so there's intrusive igneous and extrusive igneous. Intrusive igneous are rocks that are cooled deep underground. Take a long time to cool. They're the big crystals. Extrusive means it's exited the earth and it cooled really fast. So those are your small crystals. But either way, it's an igneous rock. So if it forms large crystals through what process? Well, that process is crystallization. Rocks on the surface are attracted by this process. So rocks on the surface, are attacked. Sorry, I can help if I read that more clearly. Are attacked by this process. Well, that is the same one we've already used before. Weathering and erosion are required to produce sediment. And some of these will obviously be used more than once. These are really good test questions, by the way. So one of the things I'm going to tell you if you're actually bothering to watch the whole video is that you will have unlimited attempts at this. And as I'm going through all the answers with you, you'll get it right. But this would be a really good thing to go back and review right before the test. And I only keep the highest score, so it's not going to hurt your grade if you go back and practice. So magma is the result of what process? Magma is molten rock. What do you have to get molten rock? You have to have melting. And coquina is a sedimentary rock that is made out of shells that have been ground up by waves and cemented together. So coquina kind of looks like a Rice Krispie bar in some cases, but you don't want to eat it because you'll break your teeth. All right, number 5. Are you ready? Scientists believe that very few, if any, of the rocks presently found on the Earth's surface are old enough to have been there since the beginning of Earth approximately 4.5 billion years ago because of the rock cycle. And that's true. If you were physically in my classroom right now, I'd be holding up a rock, and it's a piece of Morton gneiss. And Morton gneiss is a gneiss, G-N-E-I-S-S, which means it's a metamorphic rock that was never melted. So it's still the same. It still has all the time reset from when it was molten. You get decay, radioactive decay. When you're molten, it kind of resets. Heat and pressure, you'll still have some of those indicators. And Morton gneiss is actually located down in southern Minnesota, in Morton, Minnesota. Morton System Saver Salt, if you ever heard of that. That rock is really old. In fact, it's, I want to say, like 2.9 billion years old, somewhere on there. I have it written on the bottom. I think it might even be a little older. And there's only a couple places on Earth you're going to find rocks older than right here in Minnesota, because we're in the middle of a massive continent, so we haven't had a lot of subduction. We haven't had a lot of where basically two plates come together and one gets pushed under and you get melted and you get reheated, and you get a lot of recycling that happens. Our ocean floors are not very old because of that recycling. So the Canadian Shield is older than rock you'll find in Minnesota. The big red rock in Australia and some rocks in South Africa are the only places you'll find rocks older. But you're never gonna, never say never, right? We have yet to find a rock that is even close to 4.5 billion years old, because when the Earth started coming together, it was basically rocks hitting and hitting. There's so much friction. Think of it as kind of this big molten blob that took a while to cool. And since when it did cool, there was a lot of recycling that happened. through the rock cycle, through weathering, through erosion, through melting. So there's very few rocks that would be, if any, that would be here since that 4.5 billion, but we can get up to 3 billion, pretty close. Which of the following is part of the rock cycle? Well, if you go back up to that first part, if it's on that chart, it's part of the rock cycle. So crystallization, okay, that's crystals forming. Yep, that's part of the rock cycle. Melting, I can melt any of the 3 rocks to go back to magma to become another igneous rock. So yep. Can it be weathered as part of the rock cycle? Breaking down material, yes. Can it be moved or transported? Yes, that's part of how you get a sedimentary rock. Does it have to be deposited through deposition? Yep, once it's deposited, then it builds up, builds up, builds up. Yep, you get a sedimentary rock. Can it be put under pressure? And if you have pressure and it cements it together, that's sedimentary. But if you put heat and pressure and take long periods of time, you can get metamorphic rock. So every single one of these is part of the rock cycle. Which of the following process is not part of the rock cycle? Well, changing temperature and pressure, that's how you get metamorphic rock. Melting and cooling, well, that's how you get igneous rock. Erosion, cementation, and deposition, although deposition should be for cementation, that would be sedimentary rock. And the last one, gabbro forming from beach erosion. No, gabbro is an igneous rock, so it's never going to form from erosion. It can be eroded. Here is one more quick video. Watch the rock cycle animation, but we're actually going to watch this one together. I'm just going to make sure there's no sound, and I don't think there is. So this is looking at, we've got subduction happening here, which was forcing this up. We've got this subducting and getting melted, and it finds a weak spot and comes up and gets erupted. So it's magma down here, it's lava once it goes through. That rock can get eroded and transported and flow down to the water where it's deposited and then buried that sediment deeper and deeper until it's compacted and cemented to get a sedimentary rock. And if it gets too close to this trench and goes down through it, after buried in compaction, it could actually go back and become heated and pressure, and it could become a metamorphic rock. Or if it goes down far enough, so we've got metamorphism there, but if it goes far enough and melts, now it goes back through the whole thing. So if weathering were not part of the rock cycle, would we still have a sedimentary rock? No. If there's no weathering, no breaking down of rock into smaller chunks, there is no sedimentary rock. It could be melted, it could be folded, but unless you have erosion, there's no sedimentary rock. So if weathering were not part of the rock cycle, could we still have sedimentary rocks? This answer should be no, you can't. I'll change that to yes and no, but no is the right answer. You should hit submit, review your answers. If you were smart enough to watch this video all the way to the end, congratulations. Usually if I'm bothering to put information actually into a worksheet, it's there to help you. Again, you can do multiple attempts at this because, ladies and gentlemen, these are some really good practical questions that will be on the test.